So the purpose of the presentation really is a high level. It's really not tool specific. It's just an approach to automating SAP overall. It works for all versions of SAP, and it obviously works for other ERP systems as well, because the approach is all based around business processes. Okay, so it does. Automating SAP takes a bit of a different approach to end-to-end testing. I always use the sort of Amazon analogy. When you're automating scripts around web-based applications, for example, often what you will find is that you're dealing with 6, 7 screens or modules at a time. If you think about Amazon, you probably go through about 5 different screens. If you were going to buy a book, you end up with the basket at the end, and then you pay for the product that you're buying. So they're fairly simple test cases. When you talk about doing SAP testing, they're very extensive end-to-end processes, and they're usually quite complex. And even within particular transactions, there are different uses for a transaction. So if you look at ME21N, which is create purchase order, for example, you can have various different types of purchase orders. You can have internal orders, you can have external orders, and each of the different types of orders will sometimes have a different order of steps that takes place when you actually interact with the transaction. So, for example, if you're creating an external order, you'll be buying something from an external vendor. It's a fairly simple process to enter the data. You enter the vendor, the purchasing group, purchasing org, etc. in there. When you come to fulfill an internal order, you've usually got an extra couple of steps in there where you click on a tab and you have to enter the cost center and the GL code, for example. So materially, both transaction, it's the same transaction that you're using, but you're actually using the transaction for 2 different purposes. So in that situation, when you come to take the model-based testing approach, you would have 2 modules for that to encompass the internal and the external orders. But it becomes more important in terms of model-based automation when you look at the number of transactions that can be tested within a process. And I've got an example around the order-to-cash process later in the presentation. The next thing is there will be extensive use of master data within the tests. It's usually very early in the test process that you enter the master data. As you roll down the end-to-end process towards the end, the data will change from entering master data to much more transactional data, which is created as you go down the process. So, for example, you create a purchase order number, a purchase rec number, sales order number. These are transactional data, as we would call it, because you can't predict what that number is going to be. SAP itself will create that number when you hit the save button. The other thing that is really needed is SAP is so big that you can't be an expert on everything. And you get a lot of people, whether they're consultants or whether they're key users or just general users of the system, who actually just specialize in one part of the SAP process, if you look at it from an end-to-end point of view. So, for example, you may want to test the entire end-to-end process for purchasing things, going through procurement, going through sales, going through billing, going through dunning potentially at the end of the process. In the manual testing world, those will generally be 4 different people that would be involved in an end-to-end test of that process. So the whole idea behind automation is to use that domain expertise to take those 4 pieces of knowledge and pull them together into one end-to-end test. And my experience is when you start doing these cross-domain processes, I often used to find out it was the first time it ever been tested properly end-to-end was when they did the automation. But the important thing is you do need that domain expertise usually from business users to be involved in creating the test process for automation. That leads into what I call proper test design. So this involves not just testing the transactions that you want to test. So, for example, it might be ME21N, MIGO, Miro, and so on in the purchase order processing. There's a lot of design element. I used to call it the thinking time. So this is planning how you are going to use the master data and how you're going to use model-based automation and create reusable processes. And And a lot of people just dive into doing it. So it's really important that the automation engineer spends a bit of time just thinking about how they're going to design the end-to-end process and what level of expertise that they need from the domain experts. And these could be SAP consultants as well, not just key users. When they build the transactional test cases, like VA01 or ME21N, they've got to be designed so that they can be reusable. And this is the Lego type of approach, which we call model-based testing. That means that you try and build as few modules for a particular SAP transaction as possible. What you don't want is 30 versions of ME21N to create purchase order within your repository. Generally, the maximum that you would really need is about 8 or 9 different versions of it to encompass all the different purchase order types, for example. And they've got to be designed in a way that they can be reused by other automation engineers so that they can just use them in a plug and play and make sure they provide the correct data to the transaction within the end-to-end test. And then, of course, you've got different approaches for some of the industry solutions. So, for example, utilities. If you're using IS utilities, for example, a lot of the testing is time-based because it's based on a meter read. So what that means is the meter read is usually the catalyst for most of the end-to-end tests. And you've obviously got multiple meter reads because you've got water, you've got gas, you've got electricity. And the meter read is taken at a point in time, which then drives the creation of the contracts and the actual invoices themselves and so on. But what happens is once you've consumed that meter read, it's gone, and then you have to wait for the next quarter. So one of the approaches you can take in this particular example, where it's time-based, you can actually use SAP's own functionality to go to as far down the process, maybe even to Dunning, do the test, end-to-end test you want, and then you would have a separate set of utilities which would basically reverse the whole process back to the meter read. And what that would mean is over a quarter's period, you could rerun that test every night. So rather than manually intervening and doing that, you can actually build a set of test cases which would actually reverse the meter readout, basically. So that goes much more back to what I was saying about proper test design. Rather than just thinking about the end-to-end test in particular circumstances, how can I make it much more efficient? Okay. I think one of the key things to understand is the way that data is used within SAP as well. You'll see the pyramid here. The structure and reference master data is stuff that's really static. So these are things like profit centers, cost centers, company codes, purchasing org, sales orgs, for example. These are very unlikely to change on a year-by-year basis unless there's some sort of major reorganization within the company. So it's really important to understand the not just things like the chart of accounts, but how SAP is structured from a master data point of view. Then you get the more stable master data, which is things like material, article, vendor, customer, business partner, contract, for example. These, once they're created, they rarely sort of change. It's very unlikely that you're going to create a material and then later, 6 months later, change it, because you usually create the material from the material master. So this is very stable data that can be used. And this type of master data is the ones that you use mostly within the automation. Then you've got conditional master data. So this is things like the vendor source pricing, for source lists, the pricing that goes against the materials, for example, pricing conditions, that type of thing. Also, if you're in manufacturing, the bills and materials, they're not likely to change very often. But also things like information records. And often when I've done automation, I've been asked to create, for example, a sales order with multiple materials on it, and then go into the condition records to check that the actual summing of the pricing is done correctly, so that the invoice shows the correct total price at the end. That's quite a core thing, and particularly within IS utilities, obviously billing and checking that the bills are correct is very important, and a lot of that is based on conditional master data. Then you've got the pure transactional data, as I mentioned earlier. This is things like purchase order number, sales order number, material document number. These are things that are created as part of the process, okay? And they are normally consumed within the end-to-end test. You may have a situation where you, for example, if you wanted to support manual testing, you could use Tosca to create, say, 100 purchase orders and store those purchase order numbers in test data server, which you've got. And then those could be used and consumed by the manual tester when they need to just have a list of POs that they can do start a manual test with. But generally, if you create your end-to-end test automation tests correctly, this data will be consumed within that test and never used again. Okay. And what I've done on the left is put a number of the different the sort of common things within core SAP that you come across, like company code, sales org, distribution channel, and that type of thing. As you know, in SAP, you've got to get the combinations of the data correctly. So for a particular company code, you've got to have the correct sales org, you've got to have the correct sales group, and then you've got to have the material that works within that organization, and you've got to have a plant that's attached to it. So this combination of data is is usually the hardest part, actually, is working out what the correct master data is actually to work with. And my experience is the quickest and fastest and most efficient way is to talk to the key users, get a couple of hours with them and get them to show you the key points of the data that they use. And as I said earlier, because the master data rarely changes, you can then reuse it in many processes going forward. So I put this one together. It's just to show a typical general SAP test case, which is order to cash. Now, order to cash means different things to different organizations. So this is just sort of a straight through on it. But the reason I put this slide together was that on the left-hand side, you can see the real world example of what happens. And I've added some of the SAP modules that are involved in it, just to give an idea that you will need more than one level of domain expertise. And on the right-hand side, it's the actual SAP language that supports this overall process. And then the next slide will show you an example set of transactions. But basically, you've got a salesperson that sells something to a customer. They capture the order. We process it. So that's through the SD module, as it used to be called. Once the order's been processed, it gets picked. You confirm it. You issue the goods. At the same time, you'll send the bill to the customer, and then you will transport the goods to the customer site. They get delivered. They'll goods receipt that they've received it, and then we can actually process the payment. Or if there's something wrong with the goods that we've provided, then we process the returns. So on the right-hand side in SAP speak, the sales org is selling the materials, the customer, and everything in bold is the SAP language to match against the process. And this is really just to reinforce what I was saying on the preceding slide. It's so important to understand what these actually mean. And particularly for the automation team, they really do need to understand the, what a material is, for example, what the sales org is, what the structure of the sales org is, and also understanding the elements within a plant, for example. So you don't just have the plant, you have the storage location, which is the physical bin where the materials are stored. And then the shipping point is the actual door that the goods are shipped and put onto a lorry. It's that type of level of knowledge, and it gives you a good understanding of the overall process then. And this is what it looks like in the real world. So there's a couple of different things on here. You'll see on the preceding slide, really, the once you capture the order, you're using the AO1 to do the sales order. But from an automation point of view, there may be some things we need to do before we actually enter the master data into the sales order. And one of the things that we may need to do is check that there's actually stock there to fulfill that order for that material or that group of materials that you're going to put onto the sales order. So from an automation point of view, you want to make sure that your test will always run. And the end game is you want these things to run overnight with no manual intervention. So what would normally happen in a manual test scenario is the user would start creating the sales order. They'll hit the save button, and then they'll find that there's no stock. So then what they will do is they will go back and start again and put stock against that plant, basically, so that sales order can be fulfilled. Now, what you don't want to do is have branching in your test, and I'll come on to this in a little bit, which would be like an if-then-else case. So if stock exists, fine, create the sales order, else go to MIGO or to MB1C and add stock with movement type 561. What you'd want to do is plan it, and this is an example of what I was talking about, designing the test case, is before you even get to creating the sales order for those materials, you would automatically go into either MIGO or MB1C and add that stock before you get to set the sales order, and that would guarantee your test will never fail. Now, what a lot of companies do is they'll put like 100,000 items for 100,000 materials against a plant, for example, just to fulfill the sales orders. And over time, when you're running these tests, you will keep consuming them, and then at one point you'll get to a point where it fails because there's no stock left. So it's far easier just to, if you've got a quantity of 5 on the materials, is proceeding going into VA01, you just run MIGO or MB1C and just do a stock movement for those 5 materials. And what I've actually seen, and I've done this in the past, is I've worked with customers where they actually start right at the beginning of the process, which is creating the material itself from the material master, then going along creating the vendor and all of the preceding master data that you need, just to probably start at a purchase rec. And they may run like 15 transactions just to do the data setup. In that circumstance, if you go right back to the beginning of the process process should never fail unless somebody, for example, changes the material master or something like that. And that would be an example of a completely robust test scenario, because it will never fail. Basically, it'd be completely hardened. I'm not saying you should do that, but that is one approach that you can take. So going back to what I was talking about, test design, it's these 3 things at the top, these ones here, which are so critical to thinking about, okay, how am I actually going to make this work? And how do I make it sustainable and reusable and robust enough that it'll run every time I do it? So from an automations team point of view, what they're trying to do is test the test all of the time to make sure that it'll work. What you don't want to be doing is searching tables, for example, for data. It just doesn't work in an automation scenario. And as I said, each one of these from VA01, VL01N, etc., this is the start of your model-based automation. So again, you don't want really more than 9 versions of VA01 to encompass all of the different sales order types that you're probably using. If you've got 30 in the repository, probably the team are not doing model-based automation properly, and consequently, they're probably not doing the test design as well. They're easy things to fix, by the way, but it's just changing the mindset to think in that way of reusability all of the time, and also that somebody else is probably going to use your version of VA01 that you created in 3 or 4 weeks' time because they've got to put together a similar process. And that's something to start embedding a way of thinking in the automation teams very early when you start. So what does automation mean? It means predictability. So for every single test that you do, it's got to be predictive, the outcome. So what that means is I know what my outcome is that I'm going to be tested. If you don't have an outcome that you're looking for, it's very much like exploratory testing. It's an experiment, okay? And what we're talking about here is really moving towards building regression test packs. So we need to know what the outcome of every end-to-end scenario actually should be, okay? Anything but that expected outcome is actually a fail. So at any point in that process, if the data's not right or you get an error message, the test should finish because you're not going to get to the outcome at the end that you want, okay? Obviously, if you're doing negative testing, then it's the other way around, and of course you can use the processes for that. But for general day-to-day testing, the automation engineer has got to know what the outcome is supposed to be, so that will really take you back to the requirements. And then you start bringing in risk-based testing and all that type of thing against the requirements, which of course you've already got in Tosca. And what we're not looking for is programs. All right, we're not using something like UFT or Selenium, which are basically programming languages. What we don't want to do is make the test more complex than the actual application that we're testing. All right. And if I mentioned earlier a situation around stock and plants, you don't want to get into a situation where you put an if-then-else type statement, as I outlined earlier, into a particular module and associated test case. What you want to do is assume that that data is always going to be correct and make sure that it's always correct before it reaches that part of the test. And what that means is you're actually solving the real problem, which is to test the application. A lot of these issues often come about because of config or you're using the wrong master data. But as I said, you don't really want to be doing anything across the end-to-end process involving if-then-else statements or while do, that type of thing. All right, and this is actually one of the reasons I put this course together, because I worked with a number of partners in the early days, and they kept asking questions like, how do I do an if-then-else statement? And I was thinking, hang on, you're probably not getting what model-based automation actually is. Okay, so this really underlines what I was saying, is the data required for the test scenario must exist before you start the execution. So, you know, you've got to have a number, you've got to have the correct stock, as I've said earlier. What we don't want to be doing is going searching tables, which is what you would probably do in manual testing. Often what will happen is that if somebody's trying to create a sales order and there's no stock, they'll go and find stock and then create the sales order around the data that's available. What we don't want to do is that type of approach, searching tables. What we want to do is plan and design the process so that it's robust, and make sure that the data that you need is available before you start the test itself. If it's not there, it probably means the process is not correct and therefore the test should fail. They've got to be designed for repeatability as well. So this is really where the model-based testing comes in. And I keep banging on about this through the whole presentation, is build once, reuse many times, as long as it's sensible to do so. What you don't want to do is try and create a version of VAO1 that encompasses the 9 different type of order types that you can possibly have within one module and associated test case, because to do that, you will start treating Tosca as a programming language, basically, which is not really the point, and that's not the value proposition for it. And as I said, naming sorry, I didn't say this. One thing that's critical to get this right is your naming conventions. So when you come to name the particular transactional test, i.e. the building blocks, the Lego blocks, they should be clearly named so that if another automation engineer is looking for a version of, in this example, create standard purchase order, they can go and immediately find it without thinking about having to build it themselves if it already exists, and then reuse that component. And the only thing that may be different is the data that you supply to the module and the associated test case. And that really is the crux of model-based automation. It should be completely data-driven. But as I said, you've got to be sensible about these things. So it's fine to have 8 or 9 versions of ME21N, provided they're all supporting different approaches within that transaction. Okay. There are some times when you do need to use a bit of logic, and I'll come on to that. But what we don't want to do is write logic to test logic, because as I said earlier, what will happen is the actual test will become more complicated than the SAP scenario. Okay, it'll make, and from a reusability point of view, as you know, every programmer's got their own different way of doing things. What it may be is that the automation engineer may have to take a test case that's pre-built and then try and work out how it works, and then you're back into the maintenance trap, basically, of trying to maintain your test cases. So really, with this slide is saying keep it as simple as possible. And what you don't want to get into a situation with, particularly in when they go to be productive tests, is asking the question, is it actually the test that's failed, or is it the application that's failed? Okay, in that circumstance, it's probably that the overall test scenario has not been designed properly. And of course, each logic branch just adds more and more complexity when you're trying to either debug it or reuse somebody else's test case. Okay, so there is one approach which is really important, which goes back to what I was saying about trying not to use logic. So the example I've got here is a very simple process which involves stock items and non-stock items. So what we don't want to do is have a a program that looks like this. So in this scenario, we've got a sales order. If the materials are in stock, we just ship it and then we bill it. If they're not in stock, we need to make them. So we'll push it through MRP to gather all the materials that are required. We'll build it to order, and then we'll ship it and bill it. Now, in the testing world of SAP, that would be two completely separate end-to-end scenarios, but the green blocks that you see would be reused in both scenarios. So what I'm saying here is we're not going to put logic into the test scenario to say what type of order is it, and do we have stock or not. What we would do is we would treat one test as a non-stock item, and the second test scenario would be a stock item. So we're not creating logic within the test scenarios. This is a fundamental concept, by the way, guys, because this will save you a lot of pain longer term, is taking this type of approach and just treating them as one end-to-end test scenario. And again, as I said, you can reuse the building blocks that you create many, many times. The only thing that you need to do is supply the right data then. And this one just gives a much more complex view of reusability, where you've got common processes that run through, but you can actually reuse. You've got 6 test cases here, but we're actually reusing a lot of the building blocks which have been created. As you'll see, the happy path really is this one, where you're going down with the brown link. That's the most common used one. But they're all using certain components, like all the processes using ME21, for example. Okay. While I'm on it, the other thing that you want to think about, and this is where you probably will need to put a little bit of logic into a particular test case, is when you come to do the approval. So depending on the approval limits, you could create a purchase order. If it's under £10, it probably doesn't need to be approved. If it's over £50, it may need to go to the requester's manager. If it's over £1,000, it may go to the manager's manager, and so on. There's normally 5 to 6 levels that you go through. What you would probably need to do for ME28, which is the approval transaction in that case, is put some looping logic in there so that you're reusing the steps that you use, looking for a particular indicator, approval indicator on the screen, and when it's not visible, you know that you've reached the end of the approval process. So that would be an example where instead of building 5 versions of ME28 to handle that, you just build one and put some logic in there, and just loop until you reach the end of the approval process, and then move on to MeGo or whatever the other transaction is. So there are some situations when you want to use logic because it makes it more efficient. That's the bit I used to love about automation, was solving those type of logic problems. Okay, so now we get to the important bit, which is the domain knowledge. All right, so let's assume a 4-week UAT cycle. All right, so what happens, you get the key users involved, they do the manual testing, they generally test the same processes every cycle, and they test them in the same way because these are obviously the end-to-end key processes. They may do a little bit of exploratory testing around that, but generally they'll have a list either generate from the BPML or from the project or whatever it is, to say you need to test these processes. They only usually test their part of the end-to-end process. So what that means is you could be in total trying to test an end-to-end process, but somebody at the beginning of the process may end up creating a purchase rec, for example, and then somebody from the procurement department will pick up the creation of the data from the purchase rec onwards, but they'll use a different purchase requisition to test their part of the process. They may end up generating a particular type of sales order when they finished, and then somebody may pick it up from the billing team, and they will probably use their own sales order to take the process forward. So you're not actually testing the end-to-end process, and you're testing bits of it, okay? But they are normally the top people that you have in the organization. They've normally been around for years. They know probably, and I've actually met people like this who know 300 or more SAP transaction codes in their head, and they know exactly what they're used for. So that it's that level of knowledge that they've got. They're not usually available to the testing team in the day-to-day world because they've got their own job to do. This is a common theme where people are not available, or they can just give you like 20 minutes or something, which is not usually enough. And usually they hate testing because it's really boring. So there's an approach that you can take where the tests that they perform could be recorded. They could be passed back to the automation engineers. All right. So you've used the UAT phase to train the domain experts to do proper recordings, which generally means before they do a recording, they need to practice the process first. But it doesn't take more than usually 20 minutes to train them to use a recording tool. All right. Then those recordings can be, obviously there's a subset that's produced, that can be pushed back into the automation team where they can harden it, because when you get the recording, you'll have hard-coded data that they're using, which is really useful. It's a good way of picking up the actual master data that's being used. But the ultimate thing is you get an end-to-end process that's been recorded with the data that you require admittedly hard-coded. Then they can be hardened and made into data-driven scripts, so you divorce the hard-coded data from the script. Then when you come to the next UAT phase, it's generally the same test that the key user ran a quarter ago. So you can turn this into a more of an approval process. So once you've got the end-to-end script completed, you can, and this is part of a thing that you need to change within the organization, a way of thinking, but basically either the key user or one of the automation team sit together, they run the recording, all right, and it should just become a sign-off process from the key user, because they supplied the original recording, they supplied the data for it, so it switches them to from being a manual tester to an approver. And what that means is they will get back at least a couple of days of their life during the UAT phase, so they can either get back and do the day job, or we can use them to create more recordings. I've used this approach successfully in a number of different companies over the years, and it's a different way of thinking, particularly from an evidence point of view. And the way that we do that is we have a standalone recorder called ARA within Tosca. It's, as I said, standalone. It's easy to use interface. It's like having a video recorder. If everybody remembers what those were, controller. But it allows us to record the business user processes. They can edit, delete if they make mistakes. They can add comments. They can say, I want to verify this field, for example. And then once they've done it, we export the recording and just push it back into the normal Commander repository. And you've got this, by the way, it's free as part of Tosca. Just to finish off, there's some things I mentioned. There is some logic that you need to put in. So what I basically talk about is 3 different types of issues. Ones you know about, ones you know that potentially could happen, and then you've got things that you don't know could happen and you've got literally no control over, basically. Okay, and when you deal with these issues, for the first 2, this is really where test design comes into, is how you handle these type of known issues. So an example of a known issue is one that I spoke about earlier, is the article and material inventory. So you can use MIGA or MB1C to put that stock into the plant before you run the sales order. The second one is usually around user roles. Most people don't really approach SAP from a role-based testing point of view. But often, if you haven't got the correct users, and particularly for the automation team when they're building, if they don't have the correct permissions and within their role to be able to do end-to-end testing across different modules, if you want to call them that, they won't be able to do that. So that's an easy thing, that you need to define what the login roles are. Conversely, you can use all of these test processes later once you've built them to do role-based testing, where you log on with particular roles to see whether they can access particular transactions within the flow. So you can reuse the tests in that way. And also, in some cases, I forget the transaction, but there's one common transaction where you have to put some delivery text in, and it has to be completely unique. So this is where you would probably create an incremental data value based on the date and the timestamp, and maybe add in some random text or something in that situation. So that would be a way of overcoming these type of particular known issues that you're going to get. So you just need to be a little bit more imaginative about it. Then there's issues that you know that exist, but you can't really remove. All right. So these are things like the system response time. Test systems are not usually production systems. So what it means is that they perform more slowly. And sometimes that will cause the automation tool to time out. All right. So you can alter the global timeout. Also, particularly when you're using interfaces, if you're posting an IDOC to a receiving system, it may not actually process that IDOC for like 20, 30 minutes because it's a test system, whereas in production, it would be processing them every 30 seconds or something. So in that case, you may either go in and push the IDOC out manually and go into the, I forget the transaction, but just accelerate and make it immediate. Or you might implement a local loop with a bit of a timeout to say, if it exceeds 30 minutes, stop the test, because obviously you've always got to have an exit for a loop. But we'll give it up to 30 minutes to actually do the posting in there. But these are things that you will learn, the automation engineers will learn about as they build the tests, and then they can actually implement that via design to get around those sort of situations. Another example with this one I came across with a customer was they were importing invoice data via OpenText, which obviously is embedded within SAP. The actual process was to manually scan it. And the guy I was working with, he said, well, you know, we can't have a manual step in the process. So I said, well, what happens if the scanner goes down? How would you enter the data on the OpenText with the invoice data? And there's obviously a transaction to do that. So what we did, we just used that transaction to push the invoice data in and remove the manual step. So sometimes you've got to think out of the box because you're trying to get to the outcome of the test and you can't always replicate these manual steps, but there's usually a way around them. Okay. And then you've got things you can do nothing about. You know, somebody's installed something incorrectly, consultants put some incorrect config through and it slipped through. The errors, there's an application error, the network's down or the system's down. So the only thing you can do is wait until everything's resolved, basically, and then rerun the tests. And then just to finish off, sometimes you will use logic. The favorite is for pop-ups. So often what you'll find is that during a test scenario, sometimes you'll get a pop-up depending on the data that you use, sometimes you won't, even though the process is the same. So one of the things that you might want to put into the process, particularly for these informational pop-ups, is just to look for the green button, for example, on the screen. If it exists, press it. If it doesn't, just carry on to the next step in the process. Okay. And again, as I said, you may have some system response problems, particularly with posting things in the back end, where you need to put a sort of wait statement in there to just wait 30 seconds or something to give it time to post. But we don't use logic to determine outcome. So the example I've got here is, you know, if you've got a particular delivery type that's coming out, you wouldn't put logic into the test to say, if it's an express delivery, go down this path and use FedEx. Or if it's non-express, go down this path and use postal service. They would be two different branches, okay? And again, the inventory one I've spoken at length about. So always try and keep the processes as distinct as possible without the if-then-else type logic in there, basically. But never trade usability for reusability. So if you come across a version of ME21N which is not fit for purpose for the process you've got, just build it from scratch, basically, to meet your process, rather than try and force fit the original version into one that you can both use. And that's it, guys.